Okay. Once again, thank you all for coming to our meetup. He's Krishna, right? He's our speaker today. So he did his bachelor in mechanical engineering from SRM and masters in product design from TU Delft, Netherlands. So he's going to run through the topic. So I'll hand over to him and he'll explain you what he's going to go over. Okay. So thanks, Krishna, for coming here and doing it. You can hold it because people would hear you clearly.
Okay, perfect. Hey, hi, hello everyone. So before I start, I would like to thank every one of you here for taking your time to be here, and of course the organizers to give me this opportunity. So before I start, I would like to know a little bit of yourself, of what background you're from, so that maybe I could direct my presentation towards it.
You continue, no problem.
My name is Karan. I'm a field researcher. I work in University. I'm working as a developer. I'm Sharan. I'm working in sales. I'm also a mechanical engineer.
I'm Mohan Raj. I work as a developer.
I'm Sashi Kumar. I also studied from SRM University. Currently, I'm working product for idea as network manager.
I'm Ayapati. I'm working with a lot of
I'm Krishna Kumar, working in Captain.
I'm working studying BA.
I'm Praveen. I'm a student. I'm Tulsi. I'm a student.
Okay. I'm Rohit. I'm a student.
I'm bachelor. I'm a student.
James Dyson.
Myself, I am mechanical engineer. I'm working in a production environment. Now the industry 4.0 and everything comes. They're collecting the data.
Okay.
Teaching and understanding what it is.
Okay, good, perfect. So before I'd like to start, I'll also like to give a how do I put it, like like a small intro. Like basically, I myself, I'm not into AI. I do not know coding. So if you have insights on how things could be better, maybe we can discuss later. I mean, after the talk. And a short introduction about myself. I think it takes some lag. I design products for impact, and I also teach about design and engineering. So this is what I do primarily. As a short story about myself of how I ended up using AI in my products. I of course had explained about my engineering undergraduate, and during my college days, I was very much keen on the emotion and the human element in engineering and design, right? Because we do have a lot of powerful tools out there, which of course it's great, but then unless it's applied somewhere, it doesn't really make an impact, right? So running through during my college days, that's my project. So that's one of the projects. So this is the affordable fitness machine for people who cannot walk. And I started off using, because I was a mechanical engineer myself, I was more into designing solutions accordingly. That's pomegranate oil extractor, which is basically it extracts the fruit inside pomegranate without causing mechanical damage to the fruits. And the way it impacts people, the people element here is that, like, so those who cultivate pomegranates, this adds value, adds source. So instead of they go through the trade people, they add value at source. this was uh, yeah. So that's another project in the remote tribal bill, where carrying water itself was very difficult, and so I had designed a water wheel which can carry like around 100 liters per trip. Okay. And after my graduation, I ended up in a job. I mean, I got placed, but then honestly, back then I felt that, but this is not what exactly I want to do with my life, right? So I ended up in the rural and tribal bill, and I was, um, as I said earlier, I was into education, into teaching children. So I was working as a teacher in these villages. And there I saw something very interesting, that children who are very unconditioned, right? They do not know about the existing technologies, advancements in technology. So when given a problem, a very complex problem of their community, they came up with very simple solutions, right? So this is a key learning for myself, because me as an engineer earlier, I used to like just use all my knowledge and create missions. But then how do you simplify it? How do you simplify the process of solving something? So that's one learning. And DHave Labs is still existing, and maybe we can talk more about it later if you're interested. Um, and these human element, along with engineering and entrepreneurship, that led to my master's in product design in Delft. And this is one of the few projects, I mean, and where I really got interested in electronics, because back in SRM, honestly, like I was like, what? No, I'm not doing electronics, right? Like I was, it was like, I'm a mechanical engineer. That's what I'm going to do. Nothing integrating technologies, no. But back then, there was a female friend of mine in my class, and she was just explaining how she was followed on the roads and how unsafe she felt. So it's like, okay, let's think about something. But this is not a solution which can be solved through machines, mechanical this machines, right? So that's the first time when I tried integrating different technologies like uh, electronics and mechanical stuff. So this is basically a device which can blind a person. So if someone is attacking, it's like a safety watch. It uses a very powerful light to flash blind a person. So that was my first project in Delft. And yeah, so here and the next major one was Excelscope, for which I'm here to share with you. So it's basically a low-cost diagnostic device which uses smartphones to detect uh, uh, like parasitemia in the blood. Um, okay, so it is like, this is the typical healthcare center in Africa. Um, so you imagine these places like Nigeria and Uganda, they have the main killer diseases or there, because it's like a tropics. And what happens is that, like, because the malaria endemic is there, people who have slight feverish symptoms, they immediately think, oh, maybe I have malaria. So let me take a malaria drug instead of going to healthcare centers. Because the problem with healthcare centers is only the level 5 health center, which is like the main hospital in India, like the hospitals in cities, the equivalent of them in Africa. Only they have labs and where they can like actually uh, find if the person has malaria or not. But all other primary health centers, they do not have any equipment. And even if they do have equipment, they don't have the people who can operate such devices, right? So this leads to people taking drugs, even if they're not infected with malaria or even any other thing. And as you might be knowing, if if there's a lot of drugs being used, especially antibiotics, there's the parasitemia might evolve to adapt to the drug. So whenever there's a new, whenever the old drug is being used, it is no longer efficient. So this is a main problem, right? And due to which there are unnecessary funding health costs being spent. So this is a short video, and I don't know if it's being played. So this is what we built to solve this problem.
The main problem we found is that the current malaria detection systems that are available in the context are either too expensive, unreliable, or not even there. So and accessible.
This system automatically runs a diagnosis, so we can do that really quick.
To make this product affordable and available for rural Africa, we decided to put a smartphone inside this product, and we use a bold lens to amplify the capabilities of the camera of the phone.
So we have developed a moving system which has been actually 3D printed. This allows us to move the blood samples underneath the phone.
Excelscope represents more than an innovative medical device. It's a public statement that can show to the world what design can really mean and can do. It's tangible, complex, it can be concrete, it can really solve problems. It's a way to define a better world. It's a way to radically improve people's life.
While we designed this product, we had done quite a market research of the existing product. And you have all sorts of like optical microscopy, which is considered the gold standard in detecting diseases. But the problem with optical microscopy is, as I said, you need a trained technician to do that, as well as it's very, very expensive getting a microscope. And you have deep learning stuff, but yeah, so I'll explain about that a little later. But with all of these, you can see with increasing accuracy means increasing cost. So this is where we lie, which we wanted to design for. High accuracy at a very low cost. Okay, so now let me tell you briefly of the way diagnostic procedure is done currently. Okay, so when a patient arrives, they take the blood sample, they put it in alcohol, they basically the alcohol prevents cross infection with the lens microscope, right? And then they need to calibrate with the focusing and stuff, and then counting itself takes 240 minutes, and in total it takes 4 hours and 40 minutes for the entire diagnostic procedure to be done, which is a lot of time, especially for these primary health centers, because most of these places do not have enough nurses or technicians to do the procedure, which means what happens is that the World Health Organization, it recommends scanning through 850 fields of use, which means each blood sample has to be scanned with 850 frames. But in reality, they don't do that. In reality, they hardly do like 15 fields of use, because or else it's like a lot of time, right? As you see. And the main design constraints that we had while designing it is that like there is no infrastructure at all, and the power is hardly for a few hours per day. And if you're going to make something optical, the calibration is going to be affected by things like shaking, like bench moving and things. So it's not like a secure place as you would find the US or Europe, where no one is allowed inside, right? Like that's not the context here. And also the time taken, yes. So, okay. So the main goal of the product was to determine if this person actually has the disease or not, and if this person can be given a drug and sent home, or they need like more complex procedures to be sent to the hospital. Which means in a more deeper level, so they need to count the number of malarial parasites per 1,000 blood cells. So that's the way they count. I'll just explain why I'm telling all these things to you. So the reason why the product needs to be automated is that the way cells are counted right now, it's very difficult, or it's even inefficient, because what they do is they look into the optical microscope, and then they have a manual device. You click once and then it says 1, 2, 3, right? So that's the way it works. And you look into the microscope and you see a malarial parasite, you tap once, and if you see a red blood cells, you tap once. Like that, if you want to do for 850 fields of use over thousands of RBCs, it's like almost impossible for a person to do. That's why in the Europe and the US, this 4 hours, it applies to Africa and maybe India, but in US and in Europe, it takes up to a week or so for one sample to be diagnosed. So now imagine if there are like thousands of people in an area being infected, and if they want to go out there, and then it's like literally impossible, right? That's why the nurses and technicians in these places, they instead go for a few fields of use so that it's done. But the problem there is the disease is not confirmed, because in the life cycle of malaria, not every stage can cause an infection, right? Like if you might have heard of the incubation period of many viruses these days. Like, so the incubation period, so there is a blood stage, like I don't want to go into depth in this regard, but there's a stage where the malaria can actually be spread from one person to another. Okay, it is important to see that thing, I mean that stage or not, but more than that, it is essential to see the number of parasitemia to confirm if the person has malaria or not. So that was the boundary of our project. More than that, it is already there. There is microscopy, there is cities, you go there, find it out. And as I said, one is lack of technicians, and also there is a lack of doctors, because technicians can just count the number of parasitemia per RBC, like 1,000 RBC. But in order to find out if this sample or this person has malaria or not, or on which stage, because there are some cases where the immune system comes into play and these cells are dead actually. You see a lot of parasitemia, but then these cells are not alive, right? Okay. So the next decision that we took was, are we going to use a smartphone or a pipe, right? But usually we tend to use pipe. I mean, I'm trying to generalize stuff, but in this context, because it was rural areas, the main design ideas that we had was, what if this whole thing can be, it can be assembled locally, so that the shipping cost is lower, or there is no even shipping cost, right? So instead of putting a pie layer, because the availability of pie in Africa is much lesser compared to a smartphone, right? You just adapt the lens and our product, and you put any model of a phone inside and it goes, and there's an app and it works. So that was an idea. So yeah, okay. So as I said, I'm not very much into AI. So first we tried with OpenCV. So what we found was the stain that was used for the cells. So okay, is there anyone who has looked into a microscope onto a blood cell, onto a blood sample? So if you can explain, what color do you see when you see inside?
After adding the stain, it looks like dark blue.
Yeah, right. So basically, if you don't add a stain, you cannot see anything. It's just like water. You cannot see any details in it. So stain is basically specific to the disease being tested. So for malaria, it was the stain, and that adds like a purple blue color. So the initial idea was, what if we don't use deep learning, we don't use CNN, but instead we just identify the colors. If it lies within this color range, that's it, right? So you don't need autofocus, you don't need any complex stuff. That's what we thought, and but then there was an error, because the way the blood has been fixed on the sample, it should be proper. So the way they do it, like as I said, they put the blood drop on the slide, they put alcohol, and then after the blood gets fixed to the slide, they need to wash it with water, so the extra stain goes away. But in these areas where there is low number of stops, what they do is, because it needs to be quick, they don't wash with water and stuff. They put the stain and they put it under the microscope. So what happens is, everything is purple. So RBC is purple, the malaria parasite is also purple, right? So it was very, very difficult to understand or count the number of parasitemia per RBC. Okay, then we wanted to try with some deep learning frameworks, and so my role here was the bridge between the team which was working on algorithms and the product design. So I myself did not develop or code anything, but it was more like decision making. And here I'm here basically to share the way AI can be implemented in actual life, real life, to create impact, right? So yeah, so we used like a custom-based YOLO model, but then we realized that the key was basically like semantic. So yeah, sorry. So this model. So the idea was, if we can compute the pixel area per frame, so that assuming that instead of taking it as how many parasitemia per 1000 RBCs, what is the percentage of area by the parasitemia compared to the total area of the frame? So that was the approach that we took, and that quite worked well. And it was also interesting that we started already getting accurate results with just 1000 training images, which we had obtained through overlay. So yeah, so I'm sure you guys all know this much better than me, but this is the results that we got. And the problem with this ball lens was that, like, as it goes radially outward, the resolution was very less. And there's a team that is working on it right now. So yeah, I'll just quickly move on. And the impact in Africa has been this. So if you take microscopy, the cost per test is around 275 rupees, and for Excelscope it's just 20 rupees. And yeah, so this is the impact that the product has made in these parts of Africa. And I think my talk was very short, right? Now I was doing some research, and I found that TB is one of the killer diseases. than malaria in India, with yeah 440,000 deaths in India, and more challenging is that it takes around 72 hours for diagnosis. So yeah, so this is something that I really want to work on with my experiences. So yeah, so if you have any ideas and questions, you can.
This malaria equipment what we are talking about, it's not here in India or it's only for Africa?
So it was designed for Africa. So basically, it was made just to find. So it was designed for the context of Africa. But
Only if we used applications.
yes, it can be used. It can be used.
The device needs internet connection
No.
for using the models and all. But you used mobile or by?
We used a mobile, but the app is being developed. But the prototype of whatever you saw here was by.
Okay.
Or maybe I can show you a very short video of how the design process was looking like. That gives some more of context and everything together. Oh, okay. Now it's slow again, and there's no audio. It's not working. The sound is not working.
Smartbox thing. It should be the display. Yeah, should be. Okay.
Closing up. Okay.
It's a different password, I guess. I'll get you the password. Until that, you hold.
What is the cost of this product? So yeah, so in Indian INR equivalent, it actually comes to around 35,000.
Are you manufacturing this?
So we have just
Made the product.
made the prototype.
So it's not implemented.
No, it's it has been tested, implemented in Africa, and made an impact as such, like prototypes. We made like 50 batches. I mean 50 units of it implemented in Africa, but then it's still not in the manufacturing phase.
So how much human intervention will be needed for this, other than placing the slide in the device?
That's it. So that's the only intervention. But then we have also made sure that it stores the images on an SD card so that it can be also checked, because the thrust on AI for medical devices is not still very much in a mature stage. So that because so basically when it's a medical product and when people know that there's a phone inside it, then they're not going to trust, right? So we also wanted to make sure that there is some human intervention in terms of understanding, seeing the
humans don't make the decision. It's what is it? That virus is a lot or less. That decision humans don't make, or do they make?
Yes. So that decision is made by the doctor.
Doctor.
Okay. But then what this does is it counts the number of paracetamol per 1,000 RB.
Okay.
So that in the primary health center, the nurse or whoever is there, so they get to decide whether this person has malaria or not. First of all, that's the first step. And then the next step, they need to understand at what life cycle it is, what other features, right? So that happens to the doctor in the main hospital.
So they will whoever is the primary health center person, in charge person will take that image and if it is
so this device also says whether this person has malaria or not. Basically.
What is the accuracy?
Accuracy, we don't have enough data to say that this is accuracy, because we, as I said, we just implemented in a few health centers in Africa. So
This is like a startup company.
I wish it would. So like answering your question directly, like no, not right now, but we are looking at opportunities in India.
You showed before the slide. Plastic.
Sorry,
Out of the blue circle, one is showed as improper.
No. It doesn't mean that is improper, but it's the total number of results had errors. This one, right?
Yeah.
This is not only that one, but this whole image. Maybe the illustration is wrong.
What is expectation from our group?
I mean, yeah, like this is just my journey and experiences, so I'm sharing with you. And yeah, if someone is interested in diagnostics of TB, maybe we can have ideas on it.
With I also done my ML and AI program in some institutions.
Okay.
Some of the, then if you wish, we can also join with you for any contribute like OpenCV or RNN.
Sure. That's
We have some projects
because
master RNN.
sure, because as I already told, like I'm not an expert in AI. Of course, would be very interesting.
I also have one of my friends. He's a doctor from dental. He wanted to some project on child care.
Okay.
On dental. Okay. He also looking for such interesting things. Maybe interesting. Okay. Let's see what happens. The AI and this is algorithm and its output. Right. And how to get the input. Yeah, right. It is the biggest challenge. Right. I think you have answer for particular problem. Right. Okay. And about I'm not very sure about DB how it's detected. I'm not very sure about it. Once that detection method cannot detect the data, definitely there will be that. Yes. Okay. AI is doing a fantastic job in very large level in cancer detection. And that is the place is now AI is playing a role. Right. Anyone if you go and speak, majority time they will tell cancer. Right. Yes. That is the area AI at this moment is playing. Now you have find it on another place. That the sensors available things and prototype boxes are available. Now only thing you have to add one or two more sensors for dental. Add one sensor. Yeah. To get dental things. Right. Yeah. Or maybe TV. Add one more sensor. Done. Yeah. Right.
So actually, the way I see it is like more than like if I may know what you mean by sensors here.
See, for example, the camera can be a sensor.
Yeah. Okay. Right.
Or maybe a temperature sensor.
Okay. Right. Makes sense.
Maybe how to detect. From our human body, we need to get some input. Right. In the digital form.
Right. So, what you say makes sense because most of the data collection in the existing products or existing diagnostic tools that use the AI, what they do is they have optical microscope and they place a camera onto the objective lens and then they process the data, which is still expensive, which still requires someone to do it, right? So I think the value addition that we did here is more of the, as you said, the way the data is collected, right?
Yes, I see two things important. Since you are done with pipe, it's a custom-made product.
Yeah, right.
And our process is a custom-made. Then it becomes a smartphone. Then only thing you need is an interface of USB. Exactly. Then whatever the input, we should be able to send it out from the sensors in a USB form to that one. So any smartphone can be used. Okay?
Exactly. And that's the entire idea here. But just that we didn't have experience with Android development, so we just stopped it there. That's the thing. But actually, this product is meant to be a smartphone-based tool. It's not a pipe-based tool.
Okay. Hey, Krishna, great presentation. I have a question. How did you collect data and how did you annotate it?
Okay, so yeah, right. So we had annotated with this one sec. So we just used this VGG annotation tool. Hello.
Okay. Yeah.
So the way we collected data is from the product that we made. So we took images in the phone.
Okay.
And edited it.
Okay. So who annotated? I mean, did you have actually doctors to do this annotation or right?
So there is this Leiden University Medical Center. near Delft.
Okay.
So,
Okay.
so we had doctors. Yeah, so basically they had guided us on that.
Okay. So can you share maybe like, how many images you annotated?
Yeah, so we annotated around like 1,000 images.
Okay. Okay.
Yeah.
So I know that you commented that your accuracy, you couldn't really comment on the accuracy aspect, but during training process, did you have any measurements around that aspect?
No,
Like,
no.
how did your model perform?
So basically, we chose the framework with whatever worked and whatever the doctor said it was accurate, right? Like it was more like that. It was not like a so we did not use a metric as such to measure the
Okay.
accuracy.
But like, even if the doctors say like out of 1,000 images, right? If you use for training, maybe you had a holdout of 200, right? I'm just throwing a number, right? In that 200, let's say like, did your model perform well for like 150? What the doctors looked at it. There are some reason for my questions, right? Since this is a diagnostic tool, the bar is generally a little high. Okay.
Yes.
And like Karan is actually doing a presentation next on efficient net, right? Maybe you want to sit through that too a little bit. Like he probably can go through a little bit of details on how to even improve this stuff.
Yeah. Sure. That will be great. Yeah. Sure.
Yeah.
Thank you. We had back then limited our data set because okay, so as I told you, the lens that we used back then, so now it's improved. We're using inverse lens mechanism, but the ball lens that we used, the resolution becomes lower and lower. So back then, my professor was mentoring this project, so he has suggested that maybe after the inverse mechanism has been completed, maybe you can get more frames. So back then we had limited only to 4.
Okay, so you have to model just because of limited data.
Yeah.
They have like calculated data set.
Okay.
I can.
Yeah, sure. That's the case. Thanks. Sure.
So which framework you are using?
I'm sorry.
Which framework you are using?
So we are. Okay. No. Yeah. The source, you mean the data set? Or?
No, whatever code that you use for training.
I'm sorry. What do you?
Have you used any code for that?
Code. So actually, we also used an existing library. That's what I said. We did not develop a code as such. Yeah.
So what library do you use?
So like.
So see this Mark CNN is like from Facebook. So it is from they use PyTorch for it. And this YOLO, they have a separate library from the author. It's called Darknet, which is implemented out of C. So both of them are open source. To answer your question, YOLO is based off Darknet, and Mark CNN is based off of PyTorch, like written in PyTorch.
Thank you.
How much the accuracy is impacted by the quality of the smartphone? And say each smartphone has a different quality. How the quality of the smartphone can affect the accuracy of it? I mean, different smartphones have different cameras.
Okay, so there are two aspects about the hardware of the camera. One is what is the size of each pixel it can see, because the size of the malaria is very small, right? So if it is like around as I remember, so it's like around 15 microns, 15 microns, then it can see. So anything less than 15 microns, if the pixel size of the image that it can capture, that's less than 15 microns, then it can see. So that's the only thing that we have, and also the angle that we can see. So if it's a wide angle lens, then it can see more number of RBCs more number of parameters per.
sample to be
No.
tested?
So for 100 patients, it takes 30 hours.
So per patient it will take around 4 hours. Huh?
15-20 minutes.
15-20 minutes. And in that human intervention will be very minimal.
Yeah, you just insert, you do other parallel tasks, and then you can get back to it.
This 15-20 minutes also, based on the multiple images you are taking from the example.
So,
how many images you are going to take? 850 images you are going to take and process it for the. I mean, is it mandatory that 850 samples you are going to?
So according to World Health Organization, for a blood test for malaria, 850 is required.
Will they get saved in that device?
Yes.
So
you have SD card, it gets saved so that the doctor can also check it.
But it will, the device will in itself, the mobile will have some internal memory. No, it won't get saved in that, right?
Not really, because everything is fixed according to product design. This phone is not allowed to be taken out because the camera has been modified, and so if you're going to take it out, everything breaks.
You 3D printed the whole the external part.
Everything is 3D.
Okay. Plastic. And you have a display. What's the glass covering
part, everything is plastic except for the motors and electronics.
No, the cover you have a glass or on top of the.
No, you don't have a glass because
no,
it's just smartphone. It's just a glass of the smartphone.
Okay.
You have any lifetime for the prototype? Like how long the smartphone can function, or is it like
Prototype.
I mean, generally the
product.
Yeah.
Okay, so unless we determine the final manufacturing, what materials we're going to use, we cannot determine the lifespan of it. But then for the prototype, if you're going to use ABS or like PLA, here it's PLA, but probably in real time it could be ABS. Yeah, so that really depends on the PLA. But as far as I know, with more sunlight exposure, it tends to break, tends to brittle.
Actually, this is indoor use, correct?
Yeah, it's indoor use. But then it really depends, right? Because in some primary health centers, so basically in Africa, the way the medical system is arranged is that you have primary health centers, you have health center 1, 2, 3, 4, 5. So if it's going to be anywhere in level 2 and 3, that has roof and stuff. But if it's a primary health center, so level 0, level 1, it could be even a camp or just a desk, and then they use it.
Here you have mentioned the power another challenge. Yeah. So are you making plans for that also?
But I mean, you mean in terms of infrastructure?
Okay.
Or
yes,
I mean within the product we have battery. Within the product we have battery, and then so the algorithm, I mean the code basically tries to finish the scan. So if it's doing at 400, it will just finish the whatever it was doing, and then it goes back to the study.
Yes, right now it's a 5-base, so you might have a external big battery or external battery. When you go for a smartphone will have the different batteries and these are the motors and the separate powers, right? And when you go to the remote villages, the charging of the units, which are required might be even, I'm not sure about the solar or whatever. Some inputs maybe then only it can survive.
Yeah, exactly. So it can last for a few hours, but then after that you need charging. Then you need to get it back to level 2 health center, for example.
Or it has to package with like a solar chargers, whatever it is. I'm not very sure about it, but that might be maybe external powers. If you given the battery pack can get out of the boxes.
Yeah, maybe it can be included, but then I don't see a point because I mean, in my opinion, even in rural areas in India, for example, even the remote tribal areas, they have smartphones. So I'm not saying there's no electricity at all. There's electricity, but only for a few hours. Maybe they could just plan and charge it, for example. Because when you add solar panel, it's going to add to the cost. I understand your.
I'm not talking about exactly what you
you mean something like charging port, right?
From the maybe direct from the solar or whatever.
Yeah, exactly. So we do have a charging port. Of course, if there's a battery, there is.
Yeah.
Yeah. Of course, I can show you an Explorer view, but I'm not allowed by the university to show what is inside.
We understand.
Yeah.
How many multicam phone can be mounted in that device?
Okay. Back then, as far as so multicam is like all 3 lenses, right?
Yeah, we have one focus lens.
Yeah, right. I'm not really sure because back in 2018, we did not come across a multi-cam lens in Africa. So we just used models which have been. Yeah, so but that's a good question. I need to think about it. If it can be modified.
Multi-cam focus
Yeah, that's true. But that really depends on the lens that we are putting in front of it.
Something that you should take move the spots with to get the 850 images, move across the full, or you can have a cam can have one snap and you can make it 850 spots.
Yeah, it can be done as long as the resolution of the phone is very high. Right. Maybe it's possible if you have a smartphone like that, and if it is available in Africa, that's possible. That's possible.
Do you save any data in the mobile for future reference for improving the accuracy of the algorithm or something like that?
That could be a good way forward, but we did not implement that.
Because as you use more data, it's going to improve your data.
Right. Yeah.
But I think since they are showing the data in the SD card, data is available. But only thing they cannot retrain the data in the smartphones. They have to get it back to the central location or servers required to retrain and rebuild and and update that.
Right. Maybe these kind of technical expertise is any ideas, suggestions?
Generally, this can happen.
Okay.
Load data, they come to the central location will happen. Where that retraining.
Or maybe it can be uploaded or something like that.
Yeah. See, once it's a digital form, you can do anything. Even you can bring it back to India.
Right.
Do all the process, then they update to that firmware itself. This is what it will update. Maybe that will be some KBs.
Right.
When you get the data only, it will be in large size. And you need a big processors required. For obviously, a marker it's not that easy job. It runs for hours together, days together.
We had to face it.
So it's required. So once you run and you get the smaller output, then push it back again. So that the accuracy can continuously. But again, you need to have a same type of similar doctors and other things that will be detected. Annotation anyway this does, correct? But corrections.
Yeah.
Not really the first time annotation not required. But second time corrections required. But the purpose is, if the purpose is detect only malaria, detect whether malaria is there or not. There's no point in understanding how big the malaria is.
Yeah, of course.
When the accuracy comes, if you are not looking at that, then the accuracy obviously it's very easy to improve.
Okay, and
wherein the cancer cases, the area is very important.
Okay.
The specific areas, the area matters. So there, when the accuracy become still a challenge.
Right. And even one question that I have for you, maybe, is that like, is it possible to train a model which can detect not only malaria but also other within the same framework? Yes, that's possible.
Okay. We can have 25, 100, but only thing is that it should be easily separable. If it is not easily separable,
okay.
See, then you get it will be confused state, correct? Then you again goes into the accuracy.
Right.
Generally, medical area they prefer to have their master pieces focused on one particular area. Then you get a. But malaria are not. Right. Tuberculosis are not. Which is much better than that. Correcting malaria, tuberculosis are not. Right. Yeah. What happened in these cases? What happened? There can be cases malaria also is there, tuberculosis also is there. Yeah. Then what will be the question mark? Then what will happen? This permutation combination keeps on increasing. Then you will get any fixation. Yeah. Okay. Yeah. Sure. Thanks.
Yeah, maybe if you have more ideas and questions, maybe we can meet later. So also allow next speaker to come.
LinkedIn or
Yeah, sure. So maybe after the talk we can meet up. Follow for comment question. Okay.
Telling like deep learning is playing no role in